Good day everyone, I am Kathy Cherlyn Ogomben, your reporter for today. My topic is about the corollary 1 and 2 of Theorem 2.4 of Greatest Common Divisor. For our corollary 1, states that if the greatest common divisor or GCD of two numbers a and b is d, then when both a and b are divided by d, the resulting numbers have a GCD of 1. And here is the proof. So before starting with the proof proper, we should observe that although a divided by d and b divided by d have the appearance of fractions, in fact, they are integers because d is a divisor both of a and of b. Now, knowing that the greatest common divisor of two numbers a and b is equal to d, it is possible to find integers x and y such that d is equal to a times x plus b times y. So upon dividing each side of the equation of d, we obtain the expression 1 is equal to a divided by d times x plus b divided by d times y. Because a divided by d and b divided by d are integers, an appeal to the theorem is legitimate. The conclusion is that a divided by d and b divided by d are relatively prime. For illustration of the last corollary, let us observe that the greatest common divisor of the two numbers negative 12 and 30 is equal 6. And the greatest common divisor of two fractions negative 12 divided by 6 and 30 divided by 6 is equal to the greatest common divisor of the two numbers negative 2 and 5 is equal to 1, as it should be. So it is not true, without adding an extra condition, that a is divisible by c and b is divisible by c together give a times b is divisible by c. For instance, 6 is divisible by 24 and 8 is divisible by 24, but 6 times 8 is not divisible by 24. So if 6 and 8 were relatively prime, of course, this situation would not arise. This brings us to corollary 2. Let us have an illustration here. Suppose a is equal to 24 and b is equal to 36. And we know that the greatest common divisor of a and b, which is our 24 and 36, is equal to 12. So we want to show that the greatest common divisor of two fractions a over 12 and b over 12 is equal to 1. So given that a is equal to 24 and b is equal to 36, we find the greatest common divisor of 24 and 36 is equal to 12. Now let's calculate a over 12 and b over 12. So a over 12 is equal to 24 divided by 12 is equal to 2. And b over 12 is equal to 36 divided by 12 is equal to 3. Now, we want to find the greatest common divisor of a over 12 and which is equal to 2, and b over 12 is equal to 3. So the only common divisor of 2 and 3 is 1. So the greatest common divisor of the two fractions a over 12 and b over 12 is equal to 1. So this example illustrates that when the greatest common divisor of two numbers a and b is equal to 12, then the greatest common divisor of the fractions a over 12 and b over 12 is equal to 1. Let us proceed to corollary 2. If a is divisible by c and b is divisible by c, with greatest common divisor of the two numbers a and b is equal to 1, then a times b is divisible by c. For the proof, inasmuch as a is divisible by c and b is divisible by c, integers r and s can be found such that c is equal to a times r, which is equal to b times s. Now the relation greatest common divisor of two numbers is equal to 1 allows us to write 1 is equal to a times x plus b times y for some choice of integers x and y. Multiplying the last equation by c, it appears that c is equal to c times 1 is equal to c times the quantity ax plus by is equal to a times C times X plus B times C times Y. So if the appropriate substitutions are now made on the right-hand side, then C is equal to A times quantity BS times X plus B times quantity AR times Y is equal to A times B times the quantity SX plus RY. So our as divisible statement that A times B is divisible by C. To prove that if A is divisible by C and B is divisible by C and the greatest common divisor of A and B is equal to 1, then A times B is divisible by C. We'll use the fundamental property of divisibility and properties of the greatest common divisor. So given that A is divisible by C and B is divisible by C, there exist integers m and n such that C is equal to A times m and C is equal to B times n. Since the greatest common denominator of divisor of A and B is equal to 1, there exist integers x and y such that A times x plus B times y is equal to 1. Now let's consider C. C is equal to A times n, which is equal to B times n. Since A times m and B times n is equal to B times n, we can express C as C is equal to the quantity A times m times x plus B quantity B times n times y. Substitute C is equal to A times m and C is equal to B times n. We get C is equal to quantity A times m times x plus quantity A times m times y, wherein C is equal to A times quantity of m times x plus n times y. Now let K is equal to m times x plus n times y. Since m, n, x, and y are integers, K is also an integer. Therefore, C can be expressed as a multiplied by an integer K. C is equal to K. This implies that A is divisible by C. Similarly, B is divisible by C, so can also be expressed as B multiplied by an integer K prime. C is equal to B times K prime. Since A and B are relatively prime, K and K prime must have a common factor of 1. Otherwise, the greatest common divisor of the two numbers A and B would not be 1. Therefore, K and K prime are integers. Now, we've shown that C can be expressed as both A times integer and B times integer. Thus, A times B is divisible by C as required. Okay, suppose we have A is equal to 3 and B is equal to 5 and C is equal to 15. We are given that the greatest common divisor of 3 and 5 is equal to 1. We need to show that A times B is divisible by C. Given that A is divisible by C and B is divisible by B, we have C is equal to 3 times 5, which is equal to 15. So both A and B divide C. Now let's check A times B is divisible by C. A times B is equal to 3 times 5, which is equal to 15. Since A times B is equal to C, A times B divides C and thus A times B is divisible by C. This example demonstrates if the greatest common divisor of the two numbers A and B is equal to 1 and both A and B divide C, then A times B also divides C. And that's all for today. And thank you for listening. Have a good day.